This was question 1 on the Australian Mathematical Olympiad in 2022. Prove that a convex pentagon with integer side lengths and an odd perimeter can have two right angles but cannot have more than two right angles. This is actually a very neat problem, so make sure to pause and try it on your own first, and if you have, here is the proof. First, this problem deals with parity. And parity is if a number is odd or even, basically. So let's say n is odd. This has the same parity as n squared because odd times an odd number would give an odd number. Same thing with even. If n was even, n squared would be even because even times even gives us an even. So we can say n and n squared have the same parity. If this makes sense, we can move on. So first, we have to prove that it can have two right angles. The key here is that this has to have an odd perimeter. So we can draw a square and then place an equilateral triangle on top of it. This would give us a pentagon with an odd perimeter because let's say one side is 1, then in total it would have 5. And it has integer side lengths and it has two right angles. So we can have a convex pentagon that has two right angles. Now we have to prove it can't have more than two right angles. First of all, let's say it has 5 right angles. Obviously that can't be true because a pentagon has to have 540 degrees. But 5 right angles gives us 450 degrees. Now 4 right angles gives us 360 degrees, meaning the last angle has to be 180 degrees, but that wouldn't give us a pentagon or a convex pentagon. So we have proved that we cannot have a pentagon that has 5 right angles and 4 right angles. Now let's deal with when the pentagon has 3 right angles. Imagine these are the 5 angles the pentagon can have. Let's just say this one's the 90-degree angle. And let's say there's another 90 angle right here. And then now, the places we can choose are all next to other 90-degree angles. So this means if we have 3 right angles and a convex pentagon, 2 of them are adjacent to each other. For example, we would have 2 right angles like this, and then now this pentagon can have a right angle here, or we might have the 3 right angles all adjacent to each other, like so. These are the only 2 cases we have to deal with. When the 3 right angles are all adjacent and when 2 are adjacent but the last one isn't. So we have to prove that this pentagon would always have an even perimeter. Now, if you look a bit closely, you can notice there is a Pythagoras triangle right here. Alright, now let's label the sides. And that's it. So now, let's consider the perimeter right now. So 2y plus 2x, and then we gotta minus these parts. This is b, so minus b minus a. And then we have to add c. That will give us the perimeter of the pentagon. Now we have to prove this is even. First, a squared plus b squared equals c squared. And remember, n and n squared have the same parity. This means a has the same parity as a squared, b has the same parity as b squared, and c has the same parity as c squared. So a plus b have the same parity as c. Hope that makes sense so far. Now, let's just rewrite this again. I can factor out the -1, get a plus b, and then we get plus c. Now, we know 2y plus 2x is even. So, if this is also even, that makes the whole perimeter even, because an even number plus an even number gives us an even number. So, c minus a plus b, is this an even number? Well, they have the same parity. And any 2 numbers, when they're subtracted with each other, if they have the same parity, it will give us an even number. For example, odd number minus an odd number gives us an even number minus an even number gives us an even number. So we can conclude that the perimeter of this pentagon would be even. Now we deal with case 2. And what we're going to do is we're going to connect the shorter line to the longer line by a perpendicular. And then now we can draw a straight line connecting like this, giving us two right angle triangles. Now let's label. Alright, well this line is also y, this is also y, because they are both connected by right angles. So y squared plus a squared, which is giving us this line. We can label this as whatever we want. I'll just do f. That is the same as b squared and c squared, because those triangles are sharing the same hypotenuse. Now again, using our n equals n squared has the same parity, we get y plus a has the same parity as b plus c. Alright, so they have the same parity, which means if I add y plus a plus b plus c, it will give us an even number. Okay, and remember the perimeter is a plus c plus b plus y, which gives us an even number, and then plus x, and then plus this x. And 2x is even, this is even plus even gives us an even. Hence, this pentagon has an even perimeter. If a pentagon has 5 right angles, it can't be a pentagon. 4 right angles, it can't be a pentagon. 3 right angles, the perimeter would be even. But 2 right angles, we can have a odd perimeter pentagon. A really nice question dealing with parities.